So 10.7, here we go. This is the end of the chapter. So tomorrow there will be a quiz titled 10.7b that'll just be like the practice test vocab, but I'll give you the practice test in just a minute. But this wraps up our reading for a while. So 1 is called heat of reaction. If you just put heat, I'll go half. Heat of reaction for a full point. 2 is exothermic. Exo is a prefix that just means things are coming out. Like if you're into comic book things, an exoskeleton is like an outside kind of thing. But exo just means out. Endo is a prefix meaning it's going in. So endothermic is 3. 4 is a reversible reaction. 5 and 6, you could pretty much say anything you want about chromium. I didn't write stuff on mine, but if you're looking at something that sounds like it was in your chromium reading, go ahead and give them their points. And that was our 6 new ones on 10.7s and chromiums. Something there. Then we've got our old words. So stoichiometry is the first one. Stoichiometry, we've been going with measurement of relative quantities of reactants and products in a reaction. Then 5 things is reactants and products, molecules of each, moles of each, relative masses of each, volumes of gases. 14's mole. 15's find the moles of known, then find the moles of unknown, then find the mass or the volume of the unknown. The 3 types are mass-mass, mass-volume, and volume-volume. What must happen is balance the equation for 21. 22 is a reactant completely used up. Excess reactant not completely used up. Theoretical is the amount of product you expect. Actual is the amount of product you obtain. Actual is less. The Y is looking for 4 things: side reactions, isolation, purification, and transferring from container to container. And I'm going to change my mind and say any 2 of those will work. Just based on the paper I'm looking at it, this one has a note on it that says take any 2, you never need all 4. Percent yield is actual divided by theoretical times 100. Molar volume, I'm hunting 22.4 liters. I would like to see the liters there, not just the number, so go half if we're short the liters. STP is 0 degrees Celsius and also 760 millimeters of mercury. Who studied gases is Gay-Lussac. And then it's a super long thing. So when gases react, I guess could be a half. Their volumes being in small whole number ratios. Feels like that could be another half to a whole. Look for small whole number ratios. If you're short a word, take a half. They should be the same temperature, be worth like a half. Should be the same pressure, that should be a half. So you put that all together. When gases react, volumes are in small whole number ratios, same temperature, same pressure. Question about scoring anything there?
What was
Number 1 on the 10.7 was heat of reaction. There's a stray 10.6 quiz out there in the trade. 1 was Gay-Lussac for that, and then number 2 was one of 2 choices. Either only use step 2 of the 3-part plan, or they have to be measured at the same temperature and pressure. Questions there? Give those back to their owners. In terms of how the next quiz changed, like I said, I'll give you the practice test vocab, but everything from what's the chapter about and down just stays the same. Today's number 2 and 3 becomes a 4-point question. It'll say name and define. So give me a name of one of them. It's one of our reactions.
Heat reaction.
Not for
Heat of reaction. Okay. Exothermic.
Exothermic is one. Endothermic's the other. What's the difference in terms of definition?
Heat is absorbed and
Yeah, which is which?
those absorbed.
Correct. So endothermic, heat is absorbed. exothermic heat is given off. Number 1 will get ditched on the next quiz, the one that'll be on the practice test. Number 4 on today goes backward. It'll ask what's a reversible reaction, and that you could start with the word never and go to the end. It's never complete because the products reform to make the original reactants, and it's like a dog chasing its tail. It just goes in circles endlessly. You produce something which turns back into what it started from, which turns again, and it just rolls. Homework off of this is from 37 to 39, and the math behind me will help you to do 37 to 39. 2 days away homework would have like 40 to 45 plus the chapter quiz, I think, is 2 days away. So the practice test is then 3 days away. Tomorrow we would have a quiz, the next day we wouldn't, and then practice test comes. Any old homework would be due by practice test day. We can look at old homework in just a second. Question about 10.7, what's up? So here's a math sample. What's different about these two equations compared to everything else you've seen in this chapter? What's a little weird?
Calories and joules.
Yeah, the calories and joules. Calories and joules, both measurements of heat. These both have heat on the right, so those are endothermic or exothermic?
Exothermic.
Exothermic. Heat's coming out. If I wanted to show you an endothermic equation,
Be on the left.
those heat numbers would have to be on the left of the arrow. But we're going to do the same thing we've been doing all chapter. There's no real difference. The same way you've been using the 2's and the 2's and the 1's, the 213 or the scientific notation numbers for coefficients just get used the same way as everything else we've been doing. So if I give you grams of anything, you're going to turn grams of anything into moles. So moles here is CH4. The mole number is always 1. The gram number you always get from table. C is 12. H is 4 total because they're each 1. So 4 1s and a 12 make 16. Then instead of having a mole-to-mole conversion, we're going to go mole to kilocalorie conversion this time, because that's just what the question asked us for. The CH4 mole number is the 1 that's invisibly there, and the kilocalorie number is 13. And you push some calculator buttons, and if you do that correctly, I'm hoping you'd show up 333 kilocalories. Question about mathing that up? So I could also start you with the heat. So if I say, well, I didn't say, the book said, we're going to burn some hydrogen, which I wouldn't suggest you try to do at home. They're going to burn some hydrogen, and they're trying to make this many joules of energy, of heat. So if they start you with joules, you first have to stick here, joules. So we've got to cancel joules. The number for joules is going to be degree. What do you suppose you'd want to convert joules to? Moles. Because we're always trying to get the moles. This whole chapter is about moles. And it would be moles of hydrogen because we asked, how much hydrogen should you burn to do this? What's our mole number for hydrogen? 2 from there. And maybe you're done. But not in this case. In this case, they want you to convert moles into grams. Mole to gram conversions, moles is always 1. Gram number we always get from periodic table. H2's total, 2. Push the buttons. We're hoping for 22 grams of hydrogen. And that's the kind of work that you're trying to do on this homework, the one that goes 37 to 39. With some other scraps of like 1H's and 2K's and stuff. The syllabus has that, all the details on it. Question about any of that? It's been a while since I've done homework questions because eclipses and all sorts of stuff have been going on. Eclipses and basketball meeting subs and a variety of things. So for sure I've answered some stuff up to 22, but I don't think I've gotten any questions from anything up. So if we're trying to go chronologically here, 3 to 22 is by far the biggest assignment, but it's the one you're already invested in because I made you start it the one day, so carry that to completion someday. 23 to 30 was both easier and shorter. 31 to 36 was easier again and shorter again. 37 to 39 I think is easier again and shorter again. So it wouldn't be the worst idea in the world to start with later homeworks and work them backward and build up some momentum, because each homework I think got easier and shorter. Does anybody have anything that you've started and got you somewhat stuck somewhere in the middle of anything on these homework problems? Anybody have anything underway but difficult? Okay, so let's cut the record and call that a day.